First, we'll review submitting those Spark applications that need executed using Spark Submit. We used this tool, which resides in the Spark bin directory, during the last module. Before we dig into its usages, we'll first get a better idea of how it works. When an application is submitted, it launches a driver which will run through the application's main method. This driver process could reside on the submitting machine or your distributed cluster's master node, depending on how it's submitted. Then, the driver asks the cluster manager for a specified amount of resources. As long as those resources are available, the cluster will spin them up for use. Then, the driver will run through the main application, building up the RDD until it hits an action, which causes the driver to trigger the execution of the DAG and manage that workflow. Once it completes, the driver continues through the main code until the entire execution is done. At that point, the resources are cleaned up. However, note that this resource cleanup could occur before the driver completes if the Spark context stop method is called before then. Now, with a better understanding of Spark Submit, let's use its help option to take a look at a number of possible usages, many of which can be used just the same with the Spark shell. First, notice that it can be used for more than just submitting a job, the core use case that we've already seen, following the pattern of Spark-submit followed by any extra submission options, then the application to submit, and any arguments to pass on to it. But you'll also see that this tool can be used to kill or monitor a submitted application. To utilize these use cases, you need to supply a submission ID and the address for your cluster's master node, of which the ID should be output as part of the submission when possible. However, these use cases are only available in version 1.3 or later for Spark Standalone or Mesos, two cluster managers that we'll review in the next section.
And, as of Spark 2.0, the run-example option was added to more easily run the examples found in the examples folder of your Spark directory, which follows the same format as a regular submit, just with the pre-built example class name.
Going back to the primary use case of submission, you'll see that there are a number of options at your disposal. We've already seen the master option, but we've only used it for local submissions, where local signifies a single CPU and local with brackets specifies the number of CPUs, with an asterisk signifying all CPUs. However, this option is more often going to be the address of a cluster manager, which, again, we'll review in the next section. Then there's the deploy mode, which only has two options, client or cluster. The mode determines where the driver of the main application will reside. If client, it'll run on the same machine that you're launching from. The plus to this is that all of the input and output is rendered on that same machine. But it requires the machine to stay connected and have a fast connection for communication. There's a lot of chatter between the workers and the driver as part of its execution management. This is usually not optimal for a large or longer running job. So we have cluster deploy mode, which means the submission will be fire and forget, spinning up the driver process on the master instead. We've already used the class option, which specifies the class containing the main method. This can be omitted if the submitted jar's manifest specifies the main-class attribute. Another option is name, which simply provides a mechanism to set the name of the submitted application. Then there's the jars or py files options, which are for supplying additional dependencies used by, but not built into the submitted jar or py file. These take a comma-separated list of files, which will be distributed to all executors. Although, recall, in Java or Scala, you can create an Uber jar to avoid this necessity. The packages and repositories options also help with dependency management. They're newer options as of 1.3 relating to the spark-packages.org website, which provides a list of external Spark utility libraries. These options provide a simple means to include such libraries for use within your submitted application. Packages expects a comma-separated list of Maven formatted strings, often specified on the website. As part of the Spark Shells options, this can be a quick way to play around with these utilities.
And in 1.5, the exclude packages option was added to more easily exclude certain dependencies in case of conflicts or possibly license concerns.
Then we have the files option, which is useful for passing auxiliary files that need to be accessible by all workers. These files will be placed in each node's working directory and can be easily accessed in the code using sparkfiles.get. Now, many of these options exist for ease of use and readability. However, they could just as well be input via the conf or properties file options, which enable the setting of any Spark key value property. Conf takes a comma-separated list of properties following the format of key equals value, while properties file is a pointer to a conf file where each line is a property and the key and value are separated by whitespace. Note that this doesn't need specified, as the default is a spark-defaults.conf file, which should reside in a conf directory at the application root. A common use case is to pass in extra Java options to each executor via the spark.executor.extraJavaOptions property. Remember that the order in which properties are loaded is first to check for any set directly in the code, then any sent through Spark Submit, followed by those set in properties files, finally falling back to Spark defaults. The last options to review before looking into clusters and cluster-specific options are those used to set the amount of memory used for the driver and for each executor. If you find your application constantly running out of memory, then these are the options you should first turn to, increasing the memory available for use in the application's workspace. The value expected is a numeric one, followed by an optional memory type postfix. If there's no postfix, bytes are assumed. Otherwise, the format expected is simply the first letter of the memory type, ranging from K for kilobytes to P for petabytes. And you can also append a B to any of these to make the byte denotation explicit.